Hey guys, welcome back to the channel and this new tutorial on advanced Python. So in previous videos, we learned about multi-threading and we have seen like in case of CPU bound process, multi-threading doesn't help to improve the performance. So for example, this process where we are trying to reduce a number, which is actually a CPU bound process, we have seen like whether we run it like two sequential operation or we run two concurrent threads, the time taken it was approximately same. So to outcome or to fix this problem, today we will learn about multiprocess. So multiprocessing is simply ability of a system to support more than one processor at the same time. Okay, and this requires a machine to have multiprocessor means that it has more than one CPU cores, the true ones, which is like sometimes we call dual core, quad core, octa core, and so on. And then there is another trick that has been used to mimic multiprocessing environment is hyperthreading. So this is a trick that makes each core look like more like two CPUs to the operating system. In that sense, operating system look a single core like two different processing units. Okay, so these are the two requirements to run the multiprocessing in that sense. So let us dive in and see like how we can implement it in Python. So let us first implement a basic CPU bound process. So let us say define CPU bound and let us pass a number and let us pass the name as well. Let us print f the process name started, and let us say the process name completed. Okay, and in between let us say while n minus is equal to 1. Okay, now let us say implement our main function, our main method. So it is simply like we will first start a timer so that we can print the time taken by the process, and also let us print f the time taken by the program is, so we can simply say time dot time minus the start. Okay, now let us simply call the, and let us define a big number which will take some time. So let us say like something like very big number. Let us call the CPU bound process twice and let us see how much time it takes. Okay, so let us name it P1. Let us call it P2. Okay, now let us run and see how much time it takes. And then we will implement the same thing with multiprocessing and then see that how much we can gain. Okay. Okay, probably let us reduce the number a little. It's too big. Let us run it. Let's stop it. Let us rerun. Okay, so it took around 7.5 seconds. And now let us implement multiprocessing. Okay, so multiprocessing is simply like we can say P1 is equal to multiprocessing dot process. So first let us import it. Then we can say process. And it is similar to the threading environment where we say target is equal to CPU bound process. And then we pass args is equal to tuple of arguments. So we pass n and we will pass name. Okay, so let us say we want to call P1 and P2, two of them. And similarly, we need to call P1 dot start first, P2 dot start, and then we need to join it, wait to complete, and p2 dot join, and we can also close it, p1 dot close, p2 dot close. Okay, now, so earlier it took 7.55 seconds. As this machine has multi-core, so we can see it here. Your machine has that capability, so we can simply go in performance, and here you can see like go to CPUs, it says like how many cores it has. So this machine has 4 real cores, and then it uses hyper-threading. So the logical processors, it has 8. Okay, so it will support multiprocessing in that sense. And one more thing to mention here is like until 8 multiprocess, it will improve. After then, it will saturate because it doesn't have more processors to improve it in that sense. Okay, so just remember that as many logical cores a machine have, that many process until it will improve. After that, it will saturate. Okay. So let us run and see, like it should finish like in half time, like 7.55 here, it should finish like in 3.25 seconds. Okay, so let us run and see it. Just to make sure, let us comment this out and let us run and see it. So both of them started and both of them completed. So it takes like 4.6 seconds. So there is some overhead of using it. And if I will run it more times, like say we want to run it 8 times. Okay, so let us say it same thing. This part is not necessary, so we'll comment it out. Now let us run, and this would complete in the same time, like 4.6 seconds. But if we increase it more, like if I will add one more thread, it will now go in like another 3.6 seconds, because this machine doesn't have many those many cores. Okay, so let us run and first see this. So you can see all 8 process has been started, and hopefully all of them will complete at the same time approximately. Okay, so it takes slightly longer, probably why this is so. We have 2 to 4 to 6 to 8, and that's okay. There is always some overhead using more threads in that sense. So you see like it is improved in that sense, probably not as we expected, but it has improved. Also, this way of using multiprocessing is a bit not optimal, I would say. So there is a separate tool that is called multiprocess pool. So that we will learn in the next video. Like instead of typing these many lines for the same task, we can simply call the multiprocessing pool and pass the function and argument just once, and internally it will do the same thing as we have been doing, but it is more optimal way. Okay, so that part we will learn in the next video. So thanks for watching. Bye for now. Take care. See you in the next.